Good morning and good afternoon to all who have joined. Thank you for joining our Yext webinar on how to use algorithms and data science to build best-in-class support solutions. We're going to be recording this session as a heads up for anybody who has to drop early or wants to be able to share this with a colleague. We are also asking that everybody stay on mute for the duration of the event until we turn that off, and we can take Q&A towards the end. If you have questions during the session, please use the Q&A feature on the bottom right of your Zoom panel. We'll be monitoring that as we go, and we'll make sure that we have time, hopefully, to catch everybody's questions. So let's go ahead and jump in. By way of introductions. So my name is Joe Jorzak. I'm the head of industry for service and support here at Yext. We also have my colleagues, Max Davish, product manager for Answers, Michael Masuich, who is our director of data science, and Karen Knight, who's one of our technical engagement managers. Today's agenda, we are going to be talking about Support Answers, which is Yext's AI search solution for customer service and support. A little bit of a brief overview, just on the context of how we look at the support industry and the support challenges that a lot of companies face, and then how that can be addressed by using Yext technology around algorithms and our knowledge graph. We'll also cover a few live demos and examples. And then we'll have a fireside chat towards the end where we're going to address some Q&A and hopefully answer any of the questions you have around how you can leverage Yext technology to create better support experiences. All right, with that, I will jump in. A little bit of background on some of the trends that are shaping the support industry. When we look at how digital experiences are being transformed, we think about how we engage with technology today. And a lot of that is now focused on natural language. When you talk to Alexa or Siri, when you're working with Google or any of the other technologies that are out there, we've become very accustomed to being able to just use our own words to ask questions. Now, it used to be that you would have to structure a question. You'd have to use Boolean logic. You'd have to put things into certain formats to be able to get the response you wanted. And that was really a pretty frustrating experience. But Google and others have done a phenomenal job of making that experience better and really teaching us that you can ask things in natural language and get really good responses. The second trend that we see impacting service and support is around AI and automation. We all as consumers want to self-serve. We want to be able to see our own resources or find our own resources when we want them, how we want them. And so we've really demanded that the brands that we engage with, that the service teams that we talk to, that they make that information available to us. And when you can't find information, you have a very strong inclination to go elsewhere. So we see organizations pouring a lot of resources into creating better self-service experiences. And a lot of that is, you see that in the form of chatbots. Chatbots, I think, have been around for a while. Some are good. A lot of them aren't. And that's an area where there continues to be a lot of innovation. But there are a lot of other kinds of self-service that we're starting to see. Some of it runs behind the scenes. And it really is around how to bring information almost kind of in a pre-programmed way to the fingertips of the people who are looking for it. And in a way that's really unobtrusive and in a way that really drives customer delight. The third area that we see happening in the support space is around this idea of it being personalized and proactive. A lot of that has been driven over the past 4 or 5 years on the marketing domain in e-commerce, using a lot of cookie technology. Again, things that people, you always click on those buttons and you don't really know what's happening behind the scenes, but you're being tracked as you go across different sites. The ability to track, where you were in a certain step or process flow has been almost ubiquitous now in terms of, where marketing technology has been deployed. And we're starting to see more of that happen in the service and support domains. We know that whole area of privacy is changing. The way cookies are being used and other technologies, tracking technologies are deployed is evolving. And so there are still really unique, but also very consumer-centric approaches to being able to understand what you're looking for and present the right information at the right time to help you accomplish your objective. And we'll talk a little bit about that today. The last piece of the trends that are really shaping how we engage with support teams, it's really on the other side of the equation. It's around what the agents are using. We have talked a lot about how virtual agents or self-service or bots are going to take over. Customer service agents are still critical. People often crave that human interaction when it's important, when it's a high-value transaction, when it's something that you just have to have confirmation that it's there, or if it's really complex and the technology can't do it on its own. But enabling that agent to be more efficient, more effective, and helping them resolve those questions, making sure that they have the information to give to you that's accurate, that's timely, is a critical step. Finding answers, though, is not easy. When we think about the way people ask questions, give 10 different people a question, they're going to ask it probably 10 different ways. The order of the words, the kind of words they use are going to be a little bit different. And it's really important to be able to understand the intent of that question, and what are they really trying to get to? Where does that information live? In many cases, that's one of the reasons why chatbots struggle. People will ask questions in different ways. And if the bot has not been trained to answer that question, it'll come back with one of those, can you ask that question again? Or let me connect you to somebody to help, which is really frustrating. And so we know that as the volume of queries goes up, then types of queries also increase. And being able to have a system that can adapt to that is really critical. So the three areas that we talk about, and we're going to be diving into as we go through our examples, we look at creating better help site search experiences. Customers, when they come to a help site, they want to be able to find the information that they're looking for. Many help sites have beautifully designed pages. It's very much of a navigation or click path driven approach, where you have sections and categories, and you have to follow the path all the way through to find that one bit of content that may be buried in a long form help article, but it's not easy to find. And you might not have a lot of time, or you just might not have the right thought process that aligns to the designer of that site, and you end up not getting there. So when we think about helping those customers who want to self-serve, and we can see here, 75, approaching 85% of customers want to be able to do this. It's around making sure that all of those resources are available. We also know that there are going to be occasions when you do have to submit that case form. And when you are doing that, it's often because you couldn't find the information. So the idea is, how do you deliver that information, that exact piece of content that's needed at that moment of need, right before that case form is submitted? And it's another way to help make sure that customers can just get about their day and not have to wait for a response from an agent, whether it's on chat, email, or even if they're going to go into a live phone. The last area is around the agent experience. As I mentioned before, agents have a tremendous number of resources behind the scenes that they're leveraging to help address customer issues. Especially the challenge now is that the agents are often newer. There's a labor shortage, as everybody knows. Getting new agents onboarded, getting them productive quickly is really challenging. And being able to help them identify what information is needed to help address that issue is a critical step. We know that agents spend a tremendous amount of time looking for content, and will create multiple bookmarks and tabs and all sorts of other ways to kind of work around that, when really the technology can provide it right at their fingertips. So with that, I want to pass the baton over to my colleague, Max Davish. Max, maybe talk a little bit more about your role at Yext, and then we'll jump into some examples.
Awesome. Sounds good. So my name is Max Davish. I'm one of the product managers who works on our Answers product. And in particular, my focus is our search algorithm. And so to that end, I work a lot with Mike Shevich, our head of data scientists. So he and I are going to go through our search algorithm, the machine learning and data science that it uses to deliver great customer experiences, and a little bit of how all of that technology works. So to begin, and those of you who are familiar with Yext have probably heard this before, but when Yext Answers, we use a multi-algorithm approach to search. This basically means that rather than treating all data as if it were the same, we use multiple different algorithms to address different types of questions and different types of content. And all of these algorithms are increasingly powered by machine learning, deep learning, and a lot of the advances in natural language processing that have taken place over the last 10 years or so. And this is why we're able to deliver a Google-like search experience to our customers and to identify the exact right answers to their questions, rather than just delivering keyword-based links, which is often the experience that you get in support. A bunch of irrelevant links to help articles that leave the user confused, frustrated, and ultimately waste more of their time. So we have a couple of algorithms that we want to focus on. Increasingly, we use machine learning in many, many different ways in our algorithm, but there's a couple kind of marquee algorithms that we want to call out. The first is that I think is especially relevant to support search is this middle algorithm called semantic text search. This relates exactly to the thing that Joe was talking about earlier, which is that especially in support, there's really a million different ways to phrase each question. I think it was about 30% of questions in the context of support have never been asked before. So what this algorithm is about is divining the intent or meaning of a user's question and matching it to your content based on that, rather than based on keywords or other heuristics. Because again, especially when we're talking about a complicated support experience, there's millions of different ways that a user can phrase a question. They're often expressing complicated ideas instead of just, typing in a single keyword. So we need an algorithm that can handle that type of question and intelligently search for content based on intent and meaning rather than just the individual words. The other algorithm that I really want to zero in on is extractive question answering, which is the algorithm that we use for searching unstructured documents. The other unique thing about the context of support search is that it really isn't enough to just find the right piece of content or article that a user is looking for. That's enough in other types of search, like if you're searching for products or people. But in the context of support search, you're often searching through long form content, help articles, things that are really dense with information. So it's not quite enough to just show the user the article or the piece of content they're looking for. We have to take it a step further and extract the appropriate span or paragraph, or maybe even the handful of couple words that answer the user's question. This saves the user time. It creates a much better experience. And this is the same technology that Google uses to produce their featured snippets. So I want to show you a couple live demos of these algorithms at work. First, I want to show demos of these algorithms working just in a vacuum, outside of the context of even search. And then I want to pass it over to Michael to talk a little bit about the actual technology and machine learning that goes into these algorithms. I'll actually start with semantic text search because this one is a little subtle and difficult to wrap your head around, but the concept is very powerful. So I want to demo this context. So let's imagine that we're searching for menu items here. If I search for something like fish, and I'm using a traditional keyword algorithm, I'm not going to find any results that don't explicitly mention that word. But a semantic algorithm understands that, okay, I don't have anything for fish specifically, but I found results for prawns, tuna, classic tuna, things like that. If I search for sandwich, a keyword algorithm would, again, find nothing, but a semantic algorithm would realize that, okay, actually a hamburger or a cheeseburger, that's a type of sandwich. I know there's a little bit of a debate about whether that's true, but it understands the meaning in these things is quite similar. So to tie this back into support, let me show you an example of a question that a keyword algorithm would struggle with, but a semantic algorithm gets very handily. If I ask here, how do I alter my data package? I see that I get this result, change or add data bundles. So to a person, we kind of recognize that, okay, how do I alter, change or add? Those phrases mean similar things. Bundles, package, those things mean similar things. But mind you, the only actual word that this result shares in common with the user's question is the word data. So if I'm using a traditional keyword algorithm, that algorithm is not going to be able to distinguish between this article or this article, which also mentions data, or this one, which also mentions data. That algorithm would have no sense of the semantics of this question, and so it would really struggle to find the right content. But by using a semantic algorithm, we're able to really deliver the right answer at the right time. So, Michael, I want to pass it over to you. Could you maybe explain to us how exactly this algorithm works under the hood and what technology it's using?
Yeah, this is cool stuff. So what's happening here? This is actually like live running our production models right now. So, well, it's our development environment, but it is the real deal. And what's happening is, when we get these queries or these strings of text coming in, what we have to do is figure out how similar one string of text is to another. So, for example, in the menu example, you have the phrase, fish, and you have to figure out how similar it is to, or tuna, you have to figure out how similar it is to prawns, for example. and then use that to sort of figure out what you should show in response to the query and sort the results and all that. And same thing with the other example about the telcos, like the data package thing. You have to figure out how similar is the phrase, how do I alter my data package to this help article entitled change or add data bundles. So that's what the problem is under the hood. And what we do is we use our, it's called an embedding model. So what it does is it converts the text and represents it as a vector of floating point numbers. And then we can run a similarity algorithm. We use cosine similarity for this one to figure out what is the similarity between this and every single thing. And furthermore, we can also use this for indexing. So when you put all of your content into your knowledge graph, we can create these embeddings of the semantic meaning of what this content is, and then be able to search that in real time. Because it's all well and good to be able to compute these embeddings in a theoretical sense, but a big part of the problem is actually serving them out. Lastly, the other thing we have to do is figure out how to retrain these things on a regular basis, because there are going to be new things that are coming up in the vocabulary and the vernacular and things people are talking about. So as an example, if you've heard of BERT, that was published in the first version of BERT was published back in 2018, which is before COVID-19. So obviously, if you don't have a system in place to retrain these models, that's a real big part of the problem as well, is you have to continue to keep them updating. And we'll talk more about that in a minute. But this is a pretty cool feature that has a lot of it's really at a core of a lot of things we do, is the semantic embedding of what people talk about. So that's how it works.
Exactly. Yeah, computing these vectors is a big part of what powers a lot of answers technology. These really long, dense semantic computer understandings of what a string of text is. This is really exciting stuff that really was not possible even 10 years ago. I want to move on to this second algorithm, extractive question answering. And again, this is the algorithm that's able to highlight the exact answer to a question, or perhaps the paragraph or excerpt from an article that's most relevant to a user's question. So here I have the biography of Michael Jordan. It's pretty long, a couple paragraphs. And I will go ahead and analyze this passage with our algorithm. And what I can do now is I can ask free-form questions of this content. And mind you, the algorithm has, has no inherent familiarity with Michael Jordan. It has never seen these questions that I'm about to ask it before. But by using natural language understanding and neural networks, it's able to produce answers. So if I asked, when was Michael Jordan born? It'll tell me February 17th, 1973. And you see here, it's highlighted the span of text that actually corresponds to this answer. If I were to ask what was Michael Jordan's initials, kind of a softball, but really still a very difficult thing to get a computer to answer. It tells me MJ. How many seasons did Michael play? He played 15. And again, you see it's highlighting the actual excerpt from the passage that's relevant to the user's question. So again, taking this back to the context of sport, if I ask a question like, how long do most phone number transfers take? I see that rather than just providing a list of articles, the algorithm is able to pull out a direct, precise answer to this user's question. I think it's easy to see why this is a much better user experience. So rather than rifling through a bunch of help articles that may or may not be relevant to this question, the user is presented with the exact answer that they're looking for, which really saves a lot of time. It saves a lot of headache, and it creates a much better customer experience. This customer has been saved 5 minutes of rifling through articles thanks to the power of AI. So similarly, I want to pass it back to Michael. Can we talk a little bit about how this algorithm is working under the hood?
Yeah, good question. So this is really cool that this is all coming together. So this has been something we've been working on for quite a while. What's happening here basically when you have this text? So let's say this is some content you put into your knowledge graph. We have to do a couple of things to it. First of all, we have to figure out what is the right relevancy of documents to retrieve in response to query. So that's relying on the semantic stuff we were just talking about. The next thing is we have to take this document and figure out how to break it up into chunks, because you might have like many paragraphs, as you can see here, that go on about a number of subjects, and you have to figure out so we have to break it up into a number of pieces. We have a segmentation algorithm that runs behind the scenes that works on this. And that's very interesting. Could be its own webinar, how you do segmentation, really interesting subject. But then the next question is, given this question, can I find any words or tokens in this that answer the question? And one of the things you also have to be careful about here is you have to watch out for impossible questions. Like, I don't want the model predicting something like, if I ask a question like, how many, who is the king of Siam exactly? There should be no answer provided for this. This is really important because you don't want to be giving people wrong information as well. So it's a couple of things. Look through first of all, take the document, retrieve the documents using semantic search, segment the documents into their appropriate chunks, find the chunk that is most relevant to the user's question, look at that particular chunk, see if there are any tokens that answer the question that was asked, and then if so, return those back to the user. That's the whole process. And this is, again, all this needs to be retrained, like all this needs to be supervised, all this we have to keep a close eye on it because you don't want to be giving people wrong answers. That would be really bad. So that's kind of how it goes. And this is running with a neural network, which is it's a derivative of BERT that we've sort of fine-tuned and customized for our particular search engine.
Exactly. And mind you, all of that has to happen in less than half a second as the user types in the search bar. So there's a ton of data science and a ton of engineering that goes into making that work. So I want to piggyback on something that you said, Michael, about retraining this algorithm and making it smarter and smarter. So like any machine learning algorithm, sometimes this algorithm is going to get it wrong. And this even happens on Google. Sometimes Google has been known to produce featured snippets that are, shall we say, less than accurate. So what we need here, especially for a really salient front and center feature like this, is a way for our admins and our end users to give feedback on these predictions. So to that end, we offer a feature right here called experience training. And so to those of you who are new to machine learning basically works by showing an algorithm a huge set of data. In this case, that data set might be pairs of questions and answers, where the question is something that the users asked, and then the answer is some excerpt from a piece of text. And we show it tens or hundreds of thousands of examples of that. And then from that, it is able to learn how to answer questions in language. And the more data that we give that algorithm, the better it's going to perform. But as is always a risk in machine learning, it may get things wrong, or it may produce answers that are partially right, but not quite. And that's why we offer admins and end users a way to train the algorithm on their own esoteric data and to make our algorithms better and smarter, and also for their feedback to immediately take effect. So in the experience training interface, you can see a series of predictions that the algorithm has rendered. In these cases, they look pretty good. So I'm going to go ahead and approve a couple of these. And what approving does is, first of all, it ensures that this prediction continues to show up in its current form, even as the algorithm gets retrained and may alter its prediction. And it also signals to the algorithm, hey, that's good, keep doing more of that. So the algorithm basically will receive a reward for that and learn that that was a good thing, I'm going to keep doing that. However, if I see an incorrect prediction, let me see if I can find one. This one looks pretty good. This one is a little long, but still good. This one, let's see. It's a good sign that I am having trouble finding these. Here's one that looks less than perfect. So if I were to reject this question, two things are going to happen instantly. First off, the algorithm is going to basically ensure that no one sees this prediction anymore, regardless of what the underlying algorithm predicts. And that happens via an override layer, where basically before the algorithm consults our machine learning models, it first asks, has the admin provided explicit feedback on this query? Have they rejected it, approved it, maybe modified it? And if so, it'll always prefer the admin's prediction, the human's prediction, so to speak, over what the machine learning model natively would do. And so it'll, in this case, if we rejected this example, it'll make sure that this query stops showing up. But what's actually more interesting is what happens then under the hood and how our models are able to literally learn from that feedback. So Michael, can you talk a little bit about our training pipeline and what happens to admin feedback and end user feedback that comes from this interface?
Yes, this is definitely a very important feature that my team has been advocating for quite a bit because we always want to have more labeled data. What happens when anyone interacts with any of these snippets in any sort of way, whether it's an admin approving or rejecting or someone thumbs downing, that gets immediately put into our labeling queue. And then we have a team of people whose job it is to look at these things and look at the context and read everything about the search and use that to judge what the correct answer should have been. And I think, when it comes to machine learning, you typically have to worry about two different things. One is misprediction by predicting everything, predicting everything a positive, and mispredicting by never giving a positive. And those are two kinds of errors you can have. So in this first example here, how long do most transfers take? If the model had predicted, a different section, that would be a sort of a positive misprediction, and you can also have a negative misprediction if it didn't predict any tokens to answer this question when there clearly is one. So our team of labeling experts looks through this, and that's their job, is to sift through all of that and understand it. And then once we have that, we retrain our models on a regular basis. When we first started doing this process, our model accuracy was around 75% or so for this particular task. And now it's in excess of 90, thanks to all the retraining that we've been doing using this procedure. Another thing that is also really important, as I was mentioning earlier, is you do want to be constantly retraining these models to reflect the changes in vocabulary that people used. I mentioned the example of COVID. No, not even a word that existed in 2018 or most of 2019 for that matter. So you always have to be looking at that kind of stuff as well and constantly retraining. This is why this is so important to do the highest quality search. Certainly in a more like relevant example is when our clients change their products and things they offer, you have to also retrain for that as well. So that's why this is super important. And also worth mentioning, we do train our models custom for every client as well. It's a big part of this. We want to get the model to have as much experience on your customer's vocabulary, because that's what we have to do.
Exactly. And that's really the beauty of machine learning, is that the algorithm can constantly get smarter and smarter just by showing it more data. We don't have to rewrite rules or reprogram the algorithm or rethink how the whole architecture works. It'll just naturally get smarter. The more data, the more experience that it has, which is really exciting. So so far we've mostly talked about the inner workings of our actual search algorithm and how we're able to answer people's questions using AI and data science. But the journey of managing a search experience extends beyond just the search itself. Another really key component here is search analytics. And search analytics can be really, really tough to kind of get, understand or digest in a meaningful way. Because, as Joe said earlier, there's really a million different ways that people can ask about any given topic. So when you look at your raw search queries, it can be difficult to kind of paint a picture of what are people actually asking for, what are they interested in, what are the prevailing topics, which questions am I answering well versus poorly. So to that end, we have a feature called search term clustering. And what this does is it uses AI and a lot of the same algorithms actually that we talked about, which Michael will expound on in a moment. But rather than using it on individual, searches and results that we're showing users, we use AI on the actual on the search queries and analytics data that's flowing through your system. So because this is a demo environment, I don't have a whole lot of search volume here. But basically what this feature is able to do is it's able to tease out trends in your search data. So it groups together similar search terms that have a similar meaning or have a similar theme, and it kind of consolidates them into what we call a cluster. So that instead of looking at a million different search queries and trying to look at their analytics or performance one by one on a search term basis, you have a much higher, 3,000 foot view of your search performance. And you're also able to isolate isolate clusters that are performing well or poorly, or that are small or large. So if I wanted to kind of figure out where the most important areas of improvement were for my search experience, what I would want to look at would be this needs attention large cluster category. And what this will do is it'll calculate all of the different topics or themes where my users are not having successful searches. They don't have high click-through rates. They may not have high knowledge graph results rates. And it's showing those to me front and center so that as an admin or as the person who's running, your support experience, I know exactly what type of content gaps I need to fill. I know exactly what questions are going unanswered. So Michael, could you tell us a little bit about how this is working under the hood?
Yeah, definitely. This is, I think, one of my favorite projects I've worked on ever has been clustering. The way this is a little bit different than some of our other algorithms in answers. So a lot of what we do with answers is what you would call supervised machine learning. So that means that, for example, if I have fish and prawns, I need a model that can predict that they are related, and if it's wrong, I can update it. Clustering is an interesting twist on that, because rather than knowing ahead of time what the answers are, you don't know what the cluster should be. You have to sort of look at the logs of the searches and figure it out. So it's considered an unsupervised problem. And so we use a clustering algorithm, which sort of walks in to your data with no expectations for how many clusters there should be, or what they mean, or where they exist. And it just looks at the patterns and uses our semantic embedding model that also runs our semantic search to find groups of things that mean the same thing. And we run this on a regular basis. It's typically every week, maybe more or less frequently, depending on search volume, but it's usually at least once a week. And what happens is we're going to go through and we run this, and we're going to generate all these clusters, and that's what powers the analytics you're seeing here. And then there's a lot of cool things you can do with that. You can say, okay, well, when I ran clustering this time, I found out that this one has a very low CTR, or this one doesn't have any good content matches, or this one's doing great. So it's just super cool, because you really get an insight into what your customers are typing right in the box. Like, people are telling you what they're looking for, and if you can just find it, you can do a lot to make it work better for them. We actually do an internal implementation of answers for our technology organization, and that is one of the most interesting things. We go through it weekly, and we look at all the questions that have come up to identify support issues within the engineering organization at Yext to find what are the problems people are having. And as a good example of this, about 2 weeks ago, we had an issue with the VPN software on all of our computers. There was an upgrade that didn't quite go as well as expected. And as soon as we did that, we looked in our clustering and saw an enormous new cluster about people asking a million different variations of VPN questions. How do I reset my VPN? How do I reinstall VPN client? All this kind of stuff. And you can see all the ways that people type it. Search queries follow what you would call a distribution with long tails, where you have this phenomenon where, as that other slide I think very eloquently showed, it's like a slot machine. You have so many ways of like writing something, and so just simply sorting by query volume is not going to cut it. You need to actually group them together by their semantic meaning, and then use that to figure out what it all is all about.
And just to show a slightly more realistic example of this, here is the actual Yext help site on that same interface that Michael was talking about, where we will actually, us as Yext employees, will go in and try to figure out, okay, what are people struggling with? And here's an example of a cluster for adding new entities. And we can see there's just a lot of ways to phrase this question. Adding a new entity, add an entity, add a new entity, add new entity. There's and these all obviously to a person, they mean the same thing. They should have the same response, but without this higher level view of the analytics and the ability to cluster together similar meaning queries, we would have a much harder time teasing out this trend. So with that, I want to pass it now over to Kara, who has been the point person on some of our most successful support customers. So
thanks. Hey everyone, I'm Kara Knight. I'm a technical engagement manager here at Yext. Like Max said, I help implement our search solution for clients that are looking to use answer search support. I'll show this example for Samsung briefly. So right here, we're on Samsung's US support website. You can see they've implemented our Yext search bar right here on the main support page. I've clicked into this to show some hard-coded prompts that they've selected for users to kind of guide towards common questions or issues that users might be having. I'm going to use a query here. Let's say I'd like a nice glass of ice to put some cold brew coffee over, but my ice maker doesn't seem to be working. I'd like to reset it. So I'm going to search, how do I reset my ice maker? This is going to take us over to their answer search results page. So as you can see here, here's the featured snippet we were talking about earlier. This is immediately taken from an entity within the Yext knowledge graph to show how to reset this ice maker. If they'd like to read more about it, this can take them directly to the troubleshooting article that has the long form text. that you can view. And then here you can also see, was this the answer you were looking for, which will then provide feedback to Samsung's team and to the Yext team to show, was this featured snippet helpful, was it not helpful? If I scroll down further, I can see some different verticals in their search experience, including videos, help articles, troubleshooting guides. This is all data in their Yext knowledge graph. Videos I like to call out specifically because this comes directly from a connector to their YouTube channel. So this is a really easy piece to implement if you have a YouTube channel that has all support videos or any other videos you'd like to show in your search experience, that can connect directly to the Yext knowledge graph and update as you add new videos to that YouTube channel. So this is a great way to kind of push these to the search results if someone is more of a visual learner, they'd like to see a video format. Just scroll a bit further to show some troubleshooting guides. Again, for the ice maker, this is within the same query. I'll just run a couple more here. So next I'll show this Samsung refrigerator ice dispenser issues. So as you can see, again, troubleshooting guides are filtering down to water and ice dispenser, refrigerators, getting to troubleshooting guides specifically for those products. You can see you can pop out to learn more on that specific troubleshooting guide. More videos, what Samsung calls answers, which is another form of sort of help article content. So this is customizable depending on if you have different verbiage that your customers are used to for the data that you'd be putting into your search experience. And then they've also got these resources pulled in as well. And I'll just show kind of what these different verticals can look like. For example, we have the all tab here. So this is similar to how Google is set up. So your all tab is really the universal tab for all search results. This shows verticals in order of what's most relevant, unless you have any sort of query rules overriding which verticals you'd like to show first. For example, if you have a preference to show your users videos, we can have those show at the top. But if you click into each of these tabs here, this is similar to if you were to look into like Google Maps or Google Shopping. This just reorders dynamically based on the search, and clicking into those will show only results within that vertical. So we have troubleshooting guides, again, videos, what Samsung calls answers, and resources. This is all specifically for this query. Great, and then lastly, I'll just show some FAQs. Run a different query here. Search for screen mirroring. And you can just see again how these are reordering. You can see FAQs here at the bottom. And this just is an accordion style that can pop out quickly, get an answer. If they'd like to view more, they can link out to an article or whatever, a call to action button you'd like there. So that's Samsung. The only other thing I'd like to call out, in the first 11 weeks of going live, Samsung saw a 19% increase in engagement with their help site. So users are finding this search very useful and are getting their answers quicker. They find this easier to get what they're looking for, so they're coming back to it. A 33% increase in customer satisfaction, and then a 45% increase in their net promoter score. So clearly some satisfied users here on Samsung's support website, and that's just within the first 11 weeks. So over time, we continue to optimize this experience based on the data we're getting on what their users are searching. We can continue to add more data to the knowledge graph, optimize how we want to order search results as the algorithm changes over time. So this is just within 11 weeks. You can imagine that continues to improve over time. And then lastly, they had 15% increase in issues resolved. So starting to get the users the answers they need in a self-serve format. So that's Samsung. I'm going to pass it back to the rest of the team so we can get through a fireside chat and start answering your questions.
Awesome. Thank you, Kara. Yeah, so we're going to move into the last portion of our session today, and I'll just put our screen back up. So for our fireside chat, we have a few questions that came in during the registration process. We want to make sure we get to those. A few questions have already been dropped into direct chat, so we wanted to be able to cover those as well. And then a few others that we've come across, through some discussions with clients. If just a reminder, if you have any other questions as we go or that have been sparked by the conversation today, please drop them into the Q&A. We'll do our best to get through everything today. So with that, one of the questions that came in early, and I'll direct this one towards Max, was around how to create the knowledge graph. Specifically, how do you connect content into the graph? What does that process look like, and really, what's the lift?
Yeah, so that's one of the hardest parts of building any support experience or any search experience, especially so in support. Fortunately, one of our biggest focuses at Yext is making it easy to populate our knowledge graph and then to maintain it once you have it. So I'll call out our data connectors framework as I think the easiest and most effective way to get data from point A to point B. Basically, data connectors is a way to take content from a variety of different sources. One is a website crawler that'll automatically spider your website and find all of the every article that you have or every web page that's relevant. And others are API sources or known partners of ours, such as Zendesk, Salesforce, Freshdesk more recently, ServiceNow, a lot of the main providers in the support service space that you may already be keeping your content with. We make it really as easy as just clicking a button to sync all of that content in Yext. So that's assuming that you have a bunch of content that's on some other system like your website or Zendesk or the like, and you want to use it in Yext, and we make that really easy. What we also do, though, is for those customers who do want to use Yext as a source of truth for certain content, or just want to manage content directly within the knowledge graph, we have a really robust system of editing data in the knowledge graph. We have a sophisticated rich text editor that you can write full-blown content right from within the platform. We also have a sophisticated system for content approvals, templating, all of those things that make it easy to enable your workflow. Let's say you have a content team and you want them using certain standard assets or an approval workflow. We make all of that possible so that whether or not Yext or some other system is the source of truth, we make it easy to get the content in. And then one final option that I would add would be our robust set of completely open APIs that we use to make it possible to build an ETL from one place to another or to write some custom connection from point A to point B.
One thing I would also add to that is one of my team's projects recently has been developing a search quality index to help us keep track across the entire platform where we're doing well and where we're not doing well. And it includes a bunch of factors. If you have any guess, what do you think the factor that is most important in the search quality index is? It's content. That accounts for about 50% of the explained variance in differences between experiences. So it really, really makes a big difference. We can have the best semantic search system in the world, but if you don't have fish and prawns on your menu.
Right.
Great point.
All right. Moving on to the next question. So what are some of the considerations that I should take into account before implementing support solutions and using its analytics? I'll direct this one to Kara, just given the experience working with the Samsung team and kind of what they thought about as they prepared to launch the solution.
Yeah, so a lot of things we take into consideration in a support solution. For Samsung specifically, we're thinking about their end user. So there's a couple of ways we implement search support solutions. For example, you could have an internal portal like we showed in the beginning with, someone's in their Zendesk experience and agents are needing to look for an answer to something to provide to the customer. With Samsung specifically, we're obviously getting directly to the customer. So we wanted to make sure we had all data that existed in their current search experience, and then make sure that we were displaying that in a way that users were comfortable with, that they had been using on the support site already, and making sure those featured snippets were really, really important. So we took a big look at the experience training and made sure that we were getting the right featured snippets to deliver on some of those large blocks of text. So a lot of Samsung's data was sort of help article related or very long form text content. We want to make sure we're displaying that in quick, easy formats for the users.
Excellent. Another question that came in with the registration: has Yext in Zendesk reduced ticket solve time or similar metrics? If so, examples. So yeah, here at Yext, we use Zendesk as our ticketing platform. And so we've been using it for a while, and we've been continuing to evolve how we deploy that platform and apply it. We also deployed the web form onto the help.yext.com. And we found that, once we've integrated support answers with that web form submission process, that case form deflection or ticket deflection increased to 38%. So, which was a huge benefit to the agent population. The ability for, again, customers to self-serve, find that information at that moment of need, and really allow the agents that we have to be able to address, more complex questions. We very much take I would call like a white glove approach to our support team. And so we want to make sure that, the more challenging topics that might come up, that we're able to address those and redirect that energy that way. We're also using the Yext AI search inside of Zendesk as well. And we're seeing great results there too. So, but those are definitely two areas that, we are definitely seeing value from using Yext internally. All right, I'll take another question. Let's see. Here we go. How well versed in data science must somebody be to take advantage of the functionality? Maybe I'll direct that one to Michael.
Yeah. Well, I would say our goal is as little as possible. So it should just work out of the box for you. Actually, Davish might have a lot more to say about that. But I think we also, just sort of speaking off the cuff here, we have a lot of ideas on ways that, like, if you want to bring some of your own data into the system, like personalization, like one of my team's next areas of focus is how do we personalize search results for people? We don't really have all the functionality for that yet, but That's a really cool topic. So right now it should just work out of the box for you. And if it doesn't, let us know and we'll address it immediately. Or use experience training. However, if you want to get fancy in the future, then there's a lot of cool stuff coming down the pipeline with personalization where you could, bring your own context to a query if you have it about your customers. So that would be a thing you could do, but you don't have to be.
Right.
Yeah. Piggybacking off of that, I feel like one of our theses is that most companies do not have a Michael or a big data science team. So they often will struggle to, take advantage of some of the exciting new AI technology and its ability to delight consumers and automate processes. So yes, definitely as a goal, I think at least originally our goal was to make it so that you didn't need a Michael and you didn't really need to know anything about data science in order to use the product. And that will always be true. But I agree with Michael. It's interesting that actually, as more and more people are having their own data science teams and people who are maybe working on personalization projects or things like that, we're increasingly thinking about ways that we can integrate our work with their work. So like Michael said, if you have your own information about who your customers are or what your products are, and your data science team has done a lot of work to produce some of those, for example, those semantic embeddings that Michael had talked about, we're thinking of ways to make it so that our platforms can kind of work together. So it's not an either or thing. I think our long-term goal is to make our technology interoperable with other parts of the data science stack while still making it work very, very well on its own and being perfectly intuitive to non-data scientists.
Excellent. One of the other questions that came in around how should I measure the value received from support solutions? So we talked a little bit about I'll take this one. We talked a little bit about the Yext example and how we've integrated with Zendesk, and we see case form deflection. Some of the other things that we work with on our clients is tracking things around self-service adoption. So to that point of Max, having that content available, being able to present that information to consumers, whenever and however they ask for it. Ideally, what you'll see is that the volume of visits, will start to, and the click-throughs in terms of the engagement with that content will increase, and we've just seen that happen with Samsung. But you'll also see that the ratio of visits to tickets submitted should grow. So you're getting more and more visits. People are able to find the content they need, and they don't need to submit those tickets. So that's an important measure. Of course, when you do have the need for that ticket to come across. You want it to be resolved as quickly as possible. So time to resolution is another important one that we track. But so there are a number of other areas that we can influence. Obviously, the ability to track all of that through the analytics and be able to identify where do you have content or knowledge gaps, where might you have specific issues that come up that are related that need to have better content created or have them be more closely linked. These are all things that we have customers using the analytics to identify and improve. All right, we'll take, I think, let's do one more question. How does Yext distinguish itself from other support solutions? So I'll pass that one over to Max.
I think that one, and I don't want to sound like a broken record, but I do think it's important. I think that most other search solutions, most other support solutions, really any natural language interface, I think has not done a great job historically of answering users' questions. I think that most times when you visit a support site or interact with a support chat bot, it's really hard to get your question answered. It does not feel like it feels on Google or Bing, where they have that almost uncanny ability to answer people's questions. And so as a result, it's no wonder that people are so often frustrated that they have to spend a lot of time sort of almost gaming the system and rephrasing their question, rephrasing their query to the chatbot, and trying to get the right answer. I think that we've done an amazing job, and so much of this is owed to Michael and his team, of taking the latest and greatest in natural language processing technology, all of the technology that makes Google so good at answering its users' questions, and bringing that to our enterprise customers and making it easy for them to use in a way that, as I said, does not require them to have their own large data science team that are really expert in that field. I think that's one. And another thing that I'll call out that maybe Kara can speak to is that we also try to make it very easy to manage that experience, both from an admin perspective and a developer perspective. So from a developer perspective, we want it to be really, really easy to use our technology in whatever portal you're managing your support, and whether that's within Zendesk or Salesforce or ServiceNow, or if you have your own custom stack and you custom built your website and so on. We want it to be really easy to integrate Yext technology. So we have a big focus on developer experience in that respect, and a lot of different SDKs and ways of building experiences that are all over the stack, that are high levels of abstraction, low levels of abstraction. And then there's the admin side, the person who's managing the content, managing the search experience. We want, as we've shown, really good tools for them to be able to tweak things and make sure that the results are exactly as they want them to be, to identify content gaps, to get really rich analytics, because those are also really tough problems to solve. It's hard. Search is a hard problem, and making it easy to administer a search experience is hard, and it's something that we focus on really heavily.
Yeah, maybe just to wrap that up, Kara forwarded or posted the link to the Samsung case study. And our contacts there, and specifically Scott Messina, talks a little bit about the size of his team and how they manage Yext. Maybe we'll wrap up on that one, Kara. Just any final comments?
Yeah, sure. I think the case study is a really useful resource. I will say on the implementation side, our implementation of a decently custom experience for Samsung took around 11 weeks. So implementing a really robust search support experience can be 8 to 10 weeks even. So it's very fast for the value you're getting out of that support answer. So not only on the implementation side, and that's getting all data in, that's customizing the search experience, really getting it completely ready to go for the users. And then the maintenance of that is very user-friendly in the Yext platform, not only for the admin, but then for whoever else on your team you'd like to give permissions to review search results, the featured snippet training, anything else like that can be trained very quickly. And then, of course, our Hitchhikers platform is a great place to learn how to utilize those pieces in the platform as well.
Awesome. Thanks, Kara. Well, I think that's a great segue. We're almost at the top of the hour. Thank you, everybody, for sticking with us. Thank you to our speakers. Kara, Michael, and Max. To learn more about our AI search solutions for customer service and support, just visit yext.com/support. There's a lot of great resources on there. You can also find, of course, the case studies we just mentioned about Samsung. We have others as well. And then, of course, as Kara mentioned, we also would love to have you join Hitchhikers. Tremendous amount of resource, background information, how-tos, and a lot of great knowledge around how to get the most out of your Yext implementation and how to apply that in different ways. So thank you, everybody, for joining. We'll send a recording out to everybody who's come. And of course, we'll make this recording available once we post it onto our Yext webinar site. Thank you all. I hope you have a great day.